I'd like to now look at some more complicated trig equations. Some trig equations we can solve by factoring. So let's look at an example. Let's say that we would like to solve 2 cosine squared of theta minus cosine of theta equals 1 on 0 to 2 pi. All right, what indicates to me that this is a different kind of solving equation than ones that I've seen previously? Well, the first big indication is that I see one of my trig functions being squared. I also recognize this somewhat as a quadratic kind of equation. In other words, I have one trig function that's squared, I have one trig function that's to the first power, and then on the right-hand side I have a constant. If this happens, try and see if you can factor. To factor, you know you must get 0 first on one side. So what I'll do is I'll subtract over the 1. So I'll have 2 cosine squared of theta minus cosine of theta minus 1 equals 0. So I've got the 0 on one side that I need. Now, try factoring as the product of two binomials. All right? The first two terms must multiply to 2 cosine squared of theta. So let's try using 2 cosine of theta and an understood 1 cosine of theta. The last two terms have to multiply to negative 1. So we need to use factors of 1 there. And then, to make sure we have the correct signs, we can think about making sure that we have a negative with that last term. That would make the outer product here negative 1 times 2 cosine of theta, which is negative 2 cosine. And then we can make this term positive, which would make the inner product 1 times the cosine of theta. And then those two terms together would add to the negative cosine of theta we have up here. So this is the proper factorization of this particular equation. From here, we know that once we have something factored, we set both of those two factors equal to 0 to solve. Sometimes when we do this, we end up with solutions that are not proper. Okay? In this particular case, I believe we will end up with good solutions, but sometimes you end up with solutions that are not proper solutions. Okay? On this first equation, we want to subtract over 1. We have 2 cosine of theta equals negative 1. Divide the 2 out. And so we have cosine of theta equals negative 1/2. On the other one, we can add over the 1. And so I have cosine of theta equals 1. And I'll put it over 1 so that it's a fraction. Now, a lot of times what this will do is it will create more solutions than we would normally have. In other words, out of this left-hand equation, cosine of theta equals negative 1/2, I expect to get 2 answers. Out of the right-hand equation, I actually expect to get 1 answer because I have a radius of 1. So total, in this particular equation, set of equations, I should get 3 answers. This particular value I know is x over r. The negative I see needs to go up with the 1, so I'm going to draw pictures. X would be negative in quadrants 2 and 3. Okay, so we're going to go ahead and label that. We have the x is negative 1, the r is 2. Okay, I can see by looking at this particular example that this creates a special triangle. The other side would be the square root of 3 in the second quadrant and negative square root of 3 in the third quadrant. And so for this particular question, I will end up with theta 1 there in the second quadrant, and then theta 2 down in the third quadrant. All right, let's figure out those values. We can see from our triangle that our reference angle is a 60-degree angle. So theta 1 is going to end up being 5 pi, theta 1 will end up being 2 pi over 3, and then theta 2 will end up being 4 pi over 3. Okay, we know the 60-degree angle is some multiple of pi over 3. We know that along So this axis is pi. We can think of that as 3 pi over 3. So we have a pi over 3 less, which is 2 pi over 3, and we have a pi over 3 more, which is the 4 pi over 3. Okay, on the other one, if we draw this, we know that this is x over r. The r value being 1 indicates that this is going to be quadrantal. All right. That being the case, we need to figure out where is x1 and where is r1 at the same time. The only place that that is going to occur is when you end up with your angle right here on 0 or on 360. So at this particular location, we see that r is 1, x is 1, and y is 0. And so in this case, we're going to say that theta 3, the third answer, is 0. This concludes this lesson on solving trig equations by factoring.